Hi everybody, welcome to Turboden Talks. We live in a linear economic model that unfortunately generates mountains of waste. There is urgency to improve waste management, and we hear a lot about sustainability, decarbonization, electrification, clean energy and such. In 2018, the European Union has adopted the Circular Economy Package in the attempt to shift away from the actual linear economy. The package introduces new waste management targets. For municipal household waste, it sets a 10% cap for landfilling and a recycling target of 65% by 2035. Let us see how moving from a recycling society into circular economy. Circular economy is all about creating value in a way that is sustainable and environmental friendly. The priority should always be to adopt new technology and policies that minimize waste creation, of course. However, it is clear how the current production methods and consumption patterns will continue to generate residual waste. Residual waste which is contaminated or too low quality to be recycled in a technical, economical and environmental feasible way. That means there cannot be true circular economy without talking about how to keep the material cycles clean, how to treat securely the waste left after recycling, and how to ensure all the value in residual waste, both energy and material, is used. Well in line with the waste management hierarchy, waste to energy is the most environmentally sound treatment for recovering value from waste which is rejected by recycling facilities. It generates energy and also enables quality recycling by recovering metals and minerals from the bottom ash. Even if the transition towards zero waste and circular economy is only just beginning, we should be realistic. Reuse and recycling can only go so far, and there will always be some residual waste. Therefore, it's paramount to avoid unsustainable routes for this waste, such as dumping, open fires, or even export to countries with low social and economical standards. Too many countries globally are still heavily reliant on landfilling. In this way, valuable resources are being buried with the risk of contaminating soil and groundwater. And most worrying, decomposing waste in landfills generates methane, a greenhouse gas 28 times more potent than CO2. In the European Union, more than 150 million tons of additional CO2 equivalent savings are possible by diverting waste, which is currently landfilled, and by substituting fossil fuel used for energy generation. Waste to energy provides a local source of baseload power that complements intermittent renewable energy sources such as wind or solar, while at the same time making countries less dependent on fossil fuel. Energy production from waste saves greenhouse gas emissions and contributes to climate protection. Most waste-to-energy plants are very efficient combined heat and power plants, providing heat to urban district heating networks as well as electricity. Curious about the latest trend in waste-to-energy? Let's learn about that from an authoritative voice.
Hi, I'm Patrick Clerens and I'm Secretary General of ESWET, the European Association for Waste-to-Energy Technology Suppliers. We want to show you how waste-to-energy will play an important role in the future. Basically, we see waste-to-energy contributing to the circularity of the economy. We see that it's integrating more, giving more community services. And we see waste, non-recyclable waste, as a resource. And that's the difference with landfilling, where you landfill the waste, it is not giving anything back to the economy, so it is not circularity. I want to show this example on the plant in Denmark, in Copenhagen. So if you agree at first that you cannot recycle all material eternally, you agree that you need to treat the residual waste and not put it just into a hole. And this is what this plant is doing. And this plant does it integrated in the community fabric. And what is happening, which is further than the local space, is obviously the energy recovery and the material recovery. So basically we recover the energy from the waste and we turn this into a low carbon energy carrier like heat or steam or electricity or even hydrogen. And we recover all the materials which we can recover, and these are quite a lot. In Germany, for example, you see that they recover 500,000 tons of metal. 500,000 tons. This is huge, the amount of metals you recover from the waste energy in Germany. And these metals do not need to be recreated from virgin material, avoiding all the related CO2 emissions. So we're contributing to recycling of these metals. Also the minerals, which are the residues from the combustion, are used for landscaping, road building and so on. In Europe, we see that the waste to energy sector goes hand in hand with recycling. Eurostat data shows that the more the countries recycle, the more they use waste to energy for the residual waste they cannot recycle. So it makes sense to look at the waste in an integrated way. And this will make more and more sense globally. We see in the world, and this is a prediction from the World Bank, that in the next 30 years the waste generation will increase by roughly 60%. This is huge. 60% more waste in the next 30 years. So this is a huge challenge for the waste sector. Today, globally, roughly 70% of the waste which is generated is dumped. So we need to make sure that all this waste in future is recycled, and then the non-recyclable part is then gotten back through waste to energy by making the material, the energy recovery. Waste to energy is helping fighting climate change. If you take the example of Wuppertal, it's a waste to energy plant which generates hydrogen. This hydrogen is coming from the energy in the waste, meaning that 50% of this energy is renewable energy from biomass. And this hydrogen is used to power buses, and now, this year, in 2020, also to power the first waste to energy truck. We see also that this CO2 which is emitted in the combustion can be captured and stored. So thereby going CO2 negative, because we capture the biomass CO2. All these services are now more and more rolled out. And we therefore believe that in future there are 6 main points where waste to energy will help. It is obviously the sectoral integration by bringing the energy, the renewable energy into the transport sector, into the heating sector. It is production of fuels, so you decarbonize the road transport. It is increasing the recovery of materials. It is integrating the plants more and more into urban fabrics and therefore helping, like the ski slope, the local community to have an added value. But it's also having the educational activities and leisure services which is done with modern plants which are more and more suitable. So, therefore we believe that the waste hierarchy is an important enabler for the waste treatment in Europe. We believe that landfill should be minimized because these resources should not be wasted and we should not have methane emissions coming from landfills. We believe that the contribution of waste to energy by recovering these metals and other materials to the circular economy must absolutely be highlighted. And finally, we believe that this technology can solve a global problem and by being exported.
Non-recyclable waste to energy helps the transition to a low-carbon circular economy. That's my take-home message for today. Waste to energy plants integrated with the urban fabric is the way to produce local and sustainable energy. As municipalities in many countries aim to become more self-sustainable and likewise urban areas advocate for self-reliance, it is important to have a wise, decentralized power generation. For this reason, along with traditional energy from waste plants, a modern infrastructure of smaller and efficient plants should also be developed. Those plants should be placed in strategic locations to reduce the impact of waste logistics to road traffic and consequently reduce CO2 emissions. And those are just few of the advantages. Think about that. Smaller, efficient plants are also much faster deployed because planning and permitting as well as grid connection procedures are easier to achieve. Also, a smaller footprint and lower chimney stacks means a lower impact on landscape. And what if you are an investor? Along with a high efficiency and state-of-the-art proven technology, you will get flexibility to be able to mitigate possible waste shortages, low capex to reduce capital exposure and financial risk, easy operation and low maintenance requirements, high availability for quicker returns, and better IRRs. Finally, with small energy from waste, a better valorization of heat and power locally is possible, with communities that could become self-sufficient in their power requirements and create new jobs opportunity locally. Decentralized waste-to-energy plant towards circular economy. Do not waste this opportunity.